So today we are here to discuss about first hop redundancy protocol, Fhrp, first hop redundancy protocol. What it is actually, why do we need? Now if you see companies, they got a big LAN and then they may have multiple ISPs to communicate to the remote networks. Here the same typical example I have taken, like we got a LAN here, and let's say that LAN is in a subnet of 10.0.0.1, 10.0.0.2, and this is a LAN switch, so this IP address on this interface, let's say faster than 00, will be of same subnet 10.0.0.3, and here 10.0.0. let's say 4. Now we got two internet service provider, and maybe one I want to be a primary, so ISP1 I want it to be a primary one, ISP2 of course secondary. So whenever ISP1 or whenever router 1 fails, I can switch over to ISP2 via router 2. That's my idea of having this first hop redundancy protocol. See, that is the first hop. R1, router 1 and router 2 are the first hop for the network that is there in the LAN. This local area network for this LAN, which one is the first hop, which is the first IP address that is going to help your packet to be routed. That's the first hop. It is the gateway of this PC, whichever the device that has got this address is the first hop device. 10.0.0.3 is there on router 1, so router 1 is the first hop. But the problem is, when router 1 fails, I want to switch over all my data plane traffic, all my traffic that goes from my LAN towards the WAN. I want to switch from router 1 to router 2 so that I can reach the WAN, I can reach the internet. That's the idea. But the problem here comes is here, the gateway address. The gateway address that we have given is the IP address of R1. But whenever router 1 fails, I want to switch to R2, whose gateway is 4, 10.0.0.4. But going down to each computer and changing the IP address as 4 is not possible. It's not practically possible. We cannot go and assign gateways on every PC one by one. It's not possible. But we want the switchover to happen. I want the packet to be sent to 4, 10.0.0.4 when router 1 fails. How this can be achieved? This can be achieved with the help of this protocol, first hop redundancy protocol. So first hop redundancy protocol takes care of it. Fhrp takes care of it. How it takes care of it? By creating a floating router. It helps to create a floating routing device. Floating router. Let's say FLO, floating router. So what is that floating router? It's a virtual router. It's not a physical one. It's a virtual router which has an IP address. Let's say the IP address is 10.0.0.254, the last IP address in the subnet. So this is going to be the IP address of this first hop redundancy protocol. In another word, this is going to be the IP address of our floating router. Now, this floating router will be active with the primary device. Let's say R1 is your primary router. See, because that is connecting to your primary ISP. So R1 you want to be a primary router. So this floating router will be working on R1, will be attached to R1, will be there with R1. If I say attached, then you may guess who attaches it. No, nothing like that. That's for our understanding. I'm saying floating router will be on R1. To say it very simple, this address will be with R1. When R1 fails, this address will be with R2. That's what when I say floating router means. This address gets swapped between, or moved between, or switched over between R1 and R2, which is our two gateways. So when active device goes down and the primary gateway goes down, this address, which you have defined it as the first hop resolution protocol address, or the floating address, or the virtual IP address, that address will move to the standby device, which is R2, the secondary device. Now R2 will start responding to this gateway. Now you see the problem solved. Now instead of writing 10.0.0.3, if I write 10.0.0.254, 10.0.0.254, all the packets will be sent to this gateway. Initially R1 will be forwarding my packets, it will be routing my packets to the internet. When R1 fails, R2 takes over the active position, the primary position, and R2 starts forwarding my packet, because this address will be with R2, my gateway address. The PCs are sending the packets to the gateway. Whoever got the address, they are going to respond. If R1 is having this address, if R1 is active, then it will be having that floating address, and R1 is going to route the packet. If R1 goes down, R2 is going to use the IP address, R2 is going to respond to the IP address, or R2 is going to have that floating router on it. So all the packets will start going via router 2. So this switchover happens dynamically. You need not to go and change the IP address from 10.0.0.3 to 10.0.0.4, which is a physical IP address on the gateway. Though this is the actual IP address, we don't give this IP address to the to the host in the LAN. We give the floating IP address. The device that is active, that is going to respond. By doing so, it solves the problem now, gateway problem. But there is another issue. What is that? The issue is with the MAC address. So far, in this computer, 10.0.0.1, the MAC address to reach 10.0.0.254 was the MAC address of router 1. Let's say the MAC address of router 1 is A, and MAC address of router 2 is B. Now this guy, switch also maintains the MAC address now. It maintains the MAC address. It knows where is AAA, it knows where is BBB. So according to the switch, AAA is with fast Ethernet 0/10, BBB is with fast Ethernet 0/20. Now the second problem need to be understood. There is another problem, ARP issue. So far, for this MAC address, according to this computer, R1 is the active device, so it will be the MAC address of R1, AAA. But when R1 goes down, R2 becomes the active device, and R2 has got the whole floating address, but you don't have R2's MAC address. You got R1's MAC address. If you send to that MAC address, the switch is going to forward it to fast Ethernet 0/0, via 0/10, which will go to router 1, which is not really active. So there is a layer 2 issue. There is a MAC address issue. So even this MAC address need to be changed from AAA to BBB. That change is not possible. The switch already has registered AAA is this way, and the ARP gets refreshed not too often. It will take a lot of time. It needs to see that this destination is not reachable, and then it has to send the ARP request as a broadcast and learn new MAC address from R2. It is not that practical. The delay time will be too high. If ARP is going to discover once this gets expired, which is not that easy. So there should be some other way. What this first hop redundancy protocol does it dynamically generates a MAC address. So instead of using AAA and BBB, even the MAC address will be floating. So let's say the MAC address is KKK. So this MAC address will be floating. So if this R1 is active device, IP address, this IP address, and MAC address, this MAC address will be with this router. So according to the computers, the gateway is 10.0.0.254 and the MAC address is KKK. It is not AA or BBB. It is KKK. So what happened when this is active, when R1 is active, packet was sent to this destination MAC address and this layer 3 IP address. And now when R1 goes down, this computer is sending the packet to this same MAC address, same IP address. It reaches the switch. Switch is trying to send via this interface fast Ethernet 0/10, but the link is down, so there is no MAC address. It again immediately floods and learns. R2 immediately responds, hey, here I am. I have moved from R1 to R2. My IP address is 10.0.0.254. This is my interface through which you can reach me, fast Ethernet 0/20. So a new MAC entry happens for KKK. That's a small time that it takes for convergence, not much time, very less time it takes, the layer 2 convergence, and the packet started switch over to router 2 gateway, and from router 2 via ISP it reaches the internet. So without we changing the gateway, without we going and changing the ARP entry, we can switch over between one active device to other active device when the primary active device fails dynamically with the help of first hop redundancy protocol. Now we got 3 protocols to do this job. First hop redundancy protocol. This Fhrp is not a protocol. Fhrp is the title, which has got 3 protocols doing the same thing what we discussed now. There are 3 protocols. One, Fhrp is 3 protocol now. One is Hsrp. Hsrp stands for Hot Standby Routing Protocol. Hot Standby Routing Protocol, Hsrp. VRRP stands for Virtual Route redundancy protocol. Virtual route redundancy protocol. VRRP. Virtual route redundancy protocol. Next is GLBP. GLBP. Gateway load balancing protocol. Gateway load balancing protocol. So Hsrp, hot standby routing protocol. Virtual route redundancy protocol. Gateway load balancing protocol. Three protocol which does first hop redundancy protocol job, first hop resolution protocol, resolving the first hop. Now, why do we need three protocol doing the same job? There are slight difference in it. So if you take Hsrp, and this protocol is Cisco proprietary. It's a Cisco proprietary protocol. Hsrp is a Cisco proprietary protocol. Now what about VRRP? VRRP is an IEEE standard. And the gateway load balancing protocol, it's again Cisco proprietary. So why we have two Cisco proprietary? We will see that. We understand, okay, VRRP is industry standard. It is found on every router. Need not to have always all Cisco routers in our domain. We can have mixture of different vendor in our domain. We can have multiple vendor routing devices. Now they can run VRRP and they can talk each other. Those things are good. But why there are two different names doing the same job and designed by the same vendor? Definitely there should be some difference. We will discuss about that. Now the standard is actually, IEEE has recognized, RFC. You can see about this Hsrp in RFC. It's a 4M, RFC number 2281. You can see about VRRP in RFC 3768. And there is no RFC for GLBP. Right. Now, where do they work? In which layer they operate? Hsrp works in layer 3. VRRP works in layer 3. Whereas GLBP works in data link layer 2. Now you are going to see the major difference between Hsrp and Hsrp and GLBP. Why Cisco has got two protocols doing the same job? Now if you use Hsrp, one will be active device, the other will be standby. So there is no load balancing. There will be only one active, either R1 or R2. Cannot be both. Same in VRRP also. Whereas in GLBP, there is no load balancing in VRRP. Whereas in GLBP, as the name says, Gateway Load Balancing Protocol, the load will be balanced between R1 and R2. That's the difference between Hsrp and GLBP. Load balancing is not there in Hsrp. If you want load balancing, we need to manually create one more Hsrp, and for few VLANs you will make R1 as active device. For other few VLANs you will make R2 as active device. Then you need to run 2 Hsrp. Whereas in Glbp you just run one Glbp and load will be balanced. Right. So the other difference is Hsrp uses, there are two versions of Hsrp anyway. There are two versions of Hsrp. Version 1 uses 224.0.0.2. Version 1, this is version 1 of Hsrp. Version 2 Hsrp, which is there by default now on all Cisco iOS version right now. So that uses another multicast address 224.0.0.102. Easy to remember. This is 2, this is 102. So that is version 2 Hsrp multicast address. So using this multicast address, they send the hello packets periodically. They discover the neighbor. Not only they discover the neighbor, they maintain the neighbor relationship. When a neighbor goes down, the hold time will expire. When the hold time expires, the other guy will become active. So multicast address is useful, same like as we use multicast in routing protocols like EIGRP, Vrrp and OSPF. Vrrp uses another multicast address 224.0.0.18. Now Glbp also uses the same multicast address that is used in version 2 of Hsrp, which is 224.0.0.102. It's the same multicast address that we saw in version 1 Hsrp. Right. Now about the port numbers. Hsrp uses UDP. All these three uses UDP because it's not a connection oriented. You got a floating router on the top, so you cannot use TCP. So you got UDP 1985 is it's the port number for Hsrp, UDP 1985. Whereas for Vrrp it is UDP 112. For Glbp it is UDP 3222. So this is what the transport port number, UDP 1985 Hsrp, UDP 11.2 means 112 for Vrrp, UDP 3222 for Glbp. Alright, what is the other difference between these three protocols? The timer. The timer, every 3 seconds the hello packets are sent out of every Hsrp device in the group. So in the top we saw the diagram, R1 and R2 is one group, Hsrp group. So you can have more also. We'll talk about the groups in some time. Now the timer is 3 seconds. Every router in the group sends the hello packet every 3 seconds. And if a neighbor is not saying hello, or if an active device is not saying hello, it will the standby device will remain standby for just 10 seconds, and the 10th second the standby device will become an active device, meaning the virtual IP address will be activated on standby device, the floating IP address. Now if you talk about the timer in Vrrp, this is a little bit complicated. Like we don't call it as hello time or hold time. Here we call it as advertised time. Advertised time in Hsrp is actually 1 second. Every second it sends the advertisement, same like hello. And there is also another timer called master downtime, same like hold time. Here we call it as master. Master will be decided that he has gone down, and the standby device or the backup device will become master once the master downtime is crossed. The master downtime is actually 3 into advertised time, that is 1. The default time is 1. 3 into advertised time plus the skew time. Now, what is the skew time? The skew time is nothing but 256 minus the priority. The default priority is 100 minus the priority. That's the algorithm. That's how it is designed. 256 minus the priority divided by 256. Now if you see here, the master downtime is 3 into advertised time, so definitely it is 3 into 1 plus queue time. Let's say if the priority is 100, you got 156 divided by 256. So you get around some fraction number, like the master downtime will be around 3 point some decimal number here, some number after the dot, right? Some fraction number, not decimal number, some fraction number down here, because you divide 150 by 250 and multiply by with this, so it will be always 3 point something. All right, so if I change the advertise time, now it will be applied here. Let's say if I make it as 2 here, so it will be 3 into 2, then the value will be different. So here, if you see the hello time, you can, if you see Hsrp, sorry, if you take Hsrp, you can configure hello time and hold time as you wish. But in Vrrp, you can configure only advertise time. Master time is determined by this formula that will be dynamically determined. So this is the formula that runs in the algorithm to determine the master downtime. Whatever you advertise, whatever the timer that you give it for advertise timer, that will be multiplied into 3 plus skew time. Skew time is equal to 256 minus priority divided by 256. Right, so that is the timer here in Vrrp. Now what about the timer in Glbp? The timer in Glbp is same like Hsrp. There is no difference. It is 3 the hello time and the hold time is 10. It's the same timer because it's both Cisco proprietary. Alright, so now when I have multiple gateway, in here we have R1 as gateway and R2 as gateway. Now which will become the primary first? Or whether R1 will become a primary or R2 will become primary, which will become primary and which will become secondary? Is there any election for primary secondary? Yes, we do. Whichever the router that has got more priority, the router that has got highest priority will become the active router. The second highest priority will become the standby. So the highest will become always the active. But initially, if you don't configure priority, that priority will be tie. Initially the priority is 100. The default priority is always 100, not only in Hsrp, even in Vrrp and Glbp. This I am telling only on Cisco router. It depends on the vendor. There are some vendors, they have given priority as 1. The default priority is 1 for Vrrp. Now, the default priority on Cisco IOS router for Hsrp and Vrrp and Glbp is 100. It's 100. Now, if I have 2 routers as a gateway and 2 routers as a gateway, both are going to have 100 and 100. So there is a tie. Then which will become the gateway, or which will become the active device? In Hsrp, that is determined by the highest priority, not only in Hsrp, in Vrrp and Glbp. So first what it will do is, it will check for the highest priority. It's the same thing on Vrrp and Glbp. Now, if there is a tie in this, then it goes with the highest IP address. The biggest IP address on the interface, this interface, 10.0.0.2, this is 10.0.0.3. So this will become active because it has got the biggest IP address. 10.0, so that's the tiebreaker. So one will be active, the other will be standby. You can have more than one standby. But this is one group of Hsrp routers. Only one can be active. That is based on the high priority. If there is a tie in priority, the highest IP address. So only one can be active. If this is active, if this goes down, this will become active. If this has got the next biggest IP address, let's say this has got 20 IP address, this has got 3. 20 is bigger, 10.20 is bigger, this is the primary, and 20.3 is the secondary, and 10.0.3 is the secondary, 10.0.0.1 you got, 10.0.0.2 you got. So this will become the primary if this primary fails. If both of this fails, this will become the primary. So the highest IP address. You can have many routers in the group. It's the same story in Vrrp. If there's a tie in the priority, it takes the highest IP address. Highest IP address, that's the tiebreaker. So same like Vrrp, you can have many number of backup device. Now in Hsrp we call the active device as primary and the backup device or the other device as this standby. In Hsrp we call primary and standby, whereas in Vrrp we call it as master backup. That's the term that Vrrp calls. Instead of calling primary, it calls it as master. Sorry, this is not primary, this is active. In Hsrp active standby, in Vrrp master backup, in Glbp you know what is Glbp, both are active. That's why load balancing happens. Active. Right. So In Vrrp, sorry, in Glbp also there is a need for some election. You may ask why both are going to be active. What sort of election? What it is? Actually, there is something called Active Virtual Gateway (AVG) and AVF, Active Virtual Forwarder. Now, Active Virtual Gateway is the one which determines the load balancing, how much load first router will take and how much load second router will take. It is AVG the router. For that there is an election, active. But if you talk about AVF, Active Virtual Forwarder, which is a data plane, see, we know that this works on what? Layer 2. So it's purely based on MAC address the load balancing happens. Now if you take AVF on the first router, AVF on the second router, you will have AVF on both the routers, but AVG will be only with one router. So to select AVG, you need the high priority router, or if there is a tie, the highest IP address. But for AVF will be there on both the routers. What is AVF? Active Virtual Forwarder. What it is? Active Virtual Forwarder. Now this is the one which has got a MAC address. Let's say the MAC address here is AAA and BBB. Now AAA and BBB will be active on both. Now who assigned this AAA and BBB? Automatically generated when you enable Glbp. Now what this AVG do is, AVG will say if there is 100 computer down, 100 computers are connected to this AVG will determine how much of load will go through R1 and how much of load will go through R2. Like 50 computers data will go via R1, 50 computers data will go via R2. Active, both will be forwarding. So let's say the first computer comes, it will take AAA as the MAC address for the gateway 10.0.0.254, the floating address. This 254 floating address will be active on both the device, but router 1 will respond to AAA MAC address and router B will respond to BBB MAC address. And first computer will get the MAC address AAA in the ARP table. Second computer will get the MAC address BBB and the gateway address is same. Third computer will get AAA. So if you see, it is like all even going via the right hand side router, which is R2, and all odd computers, computer number 1, computer number 3, they go via router 1. So load balancing happens and both are active, but AVF is forwarding traffic for all odd number computers down in the access layer, and AVF on router 2 is active for all computers that are in even number 2, 4, 6, 8. That's how there is active. But for selecting AVG, who determines the forwarders, how many number of see, you can have many forwarders. You can have up to 1024 forwarders. Sorry. You can have up to 4 forwarders. You can have up to 4 forwarders. 4 forwarders. You got 4 routers. 4 routers in the group. You can have up to 4 forwarders. So if I have 100 computers, 25 computer traffic will go via router 1, 25 computer traffic will go via router 2, the other 25 will go via router 3, the last 25 will go via router 4. So those load balancing happens based on the MAC address. You got 4 MAC address generated dynamically generated and given by AVG and distributed by AVG, and for that AVG election there is a need for a priority or the IP address. Okay, next is, what if I have the active device? Let me redraw this, or I'll draw down. I got active device and standby device. In Hsrp we call it as active and standby. Now active goes down and standby becomes active. Now when active comes back, active is back, what will be the role? By default the role will go to standby. Why? Because by default the preemption is off. Preemption should be configured to make this active device to take its position back when it comes back. For this active router to become an active again when it comes back, you need to enable preemption. By default, preempt is disabled. See, you may have priority 110. The default priority on both sides is 100. So here you didn't change. So the priority is 100. Here you have changed as 110. So this is an active device. The active device goes down. This becomes active. When it comes back, though the priority is bigger, because the preempt is disabled, it cannot retain its active position. It has to go as a standby. Why? When already there is an active, this cannot become an active, though it has got the biggest priority. To become active, both should come up in the same time. Otherwise, we need to enable preemption. What is preemption? When I enable preemption on this router, as soon as this comes back from the fall, it went down and it is coming back. As soon as it comes back, it will say to the other guy, hey, I am the active device. The reason is I got more priority than you. See, they keep sending hello packets every 3 seconds, you know that. In that hello packet, one router will know about the other router's priority, IP address, all the stuff. So router A will say, or the old active device, which comes back again from the down, it will take its position immediately if the preemption is enabled. By default, preemption is disabled. We need to enable preemption. Whereas in Vrrp, by default, preempt is enabled, is on. Preempt is on by default. So here no problem. If master goes down, here we call it as master and backup. If master is going down, the backup will become the master. And when the master comes back, master will retain the master's position, because the preemption is enabled, is on by default. Whereas in Glbp, it's same like Hsrp. Preempt is disabled for AVG or active device. We saw here AVG, one will be active and the other will be standby. Whereas the forwarder, will be active on both. Some forwarders will be active on R1, some forwarder will be active on the other one. Depends on the MAC address. A will be active for 50 computers, B will be active for another 50 computers. So A will be with router 1 and B will be with router 2. Now if B goes down, router 1 will take the load of A and B. Likewise, if router A goes down, router 1 goes down, router 2 will take care of all traffic A and B. So for that, preemption is there. For AVF, for forwarder, there is a preemption, but for AVG, we need to enable preemption. That forwarder concept is not there in Vrrp and Hsrp. So if you see simply for the active device, preemption is disabled by default, you need to enable in Hsrp. Same like that, preemption is disabled in Glbp, you need to enable it. Alright, now here when I was talking, I was saying that we need to define an IP address to be a floating IP address. Yeah, we can give any IP address in that same subnet which you have in LAN. In LAN I have 10.0.0.0 subnet, so I am giving the same subnet with some other host address, host number. Whereas the MAC address is dynamically assigned. The MAC address is dynamically assigned, but for all these three protocols, the MAC address is not same. For Hsrp, the MAC address will be this 0000.0c 07 AC and then the group ID. This GG is not actually the part of address. When we enable Hsrp, we will give a group number. If that group number is 1, then this GG will become 01. Now this one is the vendor. So if you take any MAC address, this portion, now if I equally divide, this is how I can equally divide. This talks about the vendor and this talks about the host. Now always 07 AC will be there for Hsrp. 07 AC is the Hsrp ID. 07 AC. This is the MAC address, and this it's a group number, and this it's a vendor. Cisco, because it is Cisco 000.0c. Cisco, it talks about Cisco vendor. It is not that Cisco is using this as the vendor ID for all devices and for all technology, that they have not like that. In here you can easily remember, that's why I am saying that 0000C. So Hsrp easy to remember. Now 07 AC is the Hsrp ID. You can see this in exam questions. What is the Hsrp ID in the below address? If you find 07 AC, then that is the Hsrp ID. Now for Vrrp, it is always this 0000.5E. It's a multicast address, right? 5E 0001 and the group number. Always this one. This is the MAC address that will be generated when you have Vrrp. If your group number is 1, then it is 01. In Glbp, it is like this. So 0007 always B4, and then this number is purely based on the number of forwarders in the group. Alright, so this number will be purely depend on the number of forwarders and the group ID. And then see, as I told you, let me repeat again why I'm saying number of forwarders. If I have more number of routers, the forwarders will be more, and more number of virtual MAC address need to be generated. Right. Now you can have up to 4 virtual forwarder, and you can have up to 1024 virtual routers per interface in GLBP group. Anyway, that is not practically being used. Now about the IPv6 support, this all these 3 supports IPv6. So you can enable for IPv6, Hsrp, Vrrp and GLBP, and you can do it as a homework after we finish this IPv4 demonstration. And if you face any problem in having Hsrp, Vrrp, GLBP and IPv6, kindly let me know. Let me fix it. Now this is what about first hop redundancy protocol. 3 different protocols, Hsrp, Vrrp and GLBP. All these 3 does the same thing. What it helps to have a floating MAC address and floating IP address, and they got different attributes. Some uses different, some work in layer 3, some work in layer 2, and the Hsrp version 2 and GLBP. Hsrp version 2 is what the default now. Hsrp version 2 and GLBP, they use both same multicast address 224.0.0.102, whereas Vrrp is 224.0.0.18, and all 3 has got different UDP for TCP session. For transport, the port number is UDP 1985. So you can easily guess why this port number, very old one. This is the year in which Hsrp was introduced by Cisco. Later came Vrrp, UDP 112, and GLBP is 3222. Now there is no reason why this number is given, but for this is the year. Now the timers are 3 and 10 for Hsrp. For Vrrp it is not like that. The hold time is not decided by the configuring person. Only the advertise timer can be configured. By default it is 1. If you change the advertised timer, based on that, the master downtime or the hold time, you need to call it as master downtime in Vrrp. That will vary based on the advertised time. So it is not always 3 times or 4 times. It is depending on the advertised timer that we give. The master downtime will vary. Whereas in Hsrp and Hsrp and GLBP, you are free to change both hello time as well as the hold time. You can have hello time as or 512 or or you can say 750 milliseconds. You can do that, and you can have hold time as every 1 second. You can do that. Even in Vrrp you can have advertised time in millisecond if you want. But only one thing is, in Vrrp you are not allowed to do changes to the master downtime, which is the hold time for Vrrp. That will be dynamically decided based on this formula. And about the priority, by default all 3 has got the same priority, 100. Now the priority comes into picture only when there is switch over. When the active device goes down, the secondary device becomes active. When the active comes back, if the preemption is enabled, then the priority will speak. Or if the priority is same, highest IP address will speak. But for that, preemption need to be enabled. But by default, preemption is disabled. You can enable it in Hsrp, whereas in Vrrp it is on by default. In Glbp it is disabled. You can on it. These are the MAC address that is used in Hsrp, Vrrp and Glbp, generated by Hsrp, Vrrp and Glbp, and we got IPv6 support in all these three. Now we are going to do the lab part of it. All these three I'm going to do lab for Hsrp, Vrrp and Glbp. Yep, I'm sorry, it is Vrrp. Vrrp don't support IPv6. Only Hsrp and Glbp supports IPv6. So there is another small change. It is not for Vrrp. It is not UDP 112. It is IP 112. It's IP 112 for Vrrp. And the multicast is same. It is 224.0.0.18. And all the other things are correct. Okay, one more thing, as we already discussed, it is not supporting IPv6. Vrrp don't support IPv6, doesn't support IPv6. It's only Hsrp and Glbp. So we got three gateways: router 1, router 2, router 3, and we are going to enable first hop resolution protocol. And this switch is just, no configuration is done on the switch. It's a normal interface to connect between the computers and the gateways, from gateway to rest of the world. R4 is an internet for us. It is acting like an internet. And these computers are actually behind the screen. They are routers. They are not really computers. So gateway can be given like this. What is gateway? Sending anything to a particular address, which is a router address that can take you to the unknown networks. That's what gateway means. So I can this is the easy way that I can make the computers to act like a computer. The routers to act like a computer. So this configuration goes on router 1. So this is the computer, this is the IP address, this is the configuration. I'm going to do it on router 1. Sorry, it's not router 1, it's host 1. So on host 1, I paste it. IP address is given, saved. And see, this address is not the real gateway address. This address is the virtual IP address. See, the address that I have assigned. Anything you don't know, you send it to this address. What is this address? This is the virtual IP address 10.0.0.24. It is not on any physical interface of any of the gateway. Okay, we got another gateway here. Actually, we got another gateway 10.0.0.6. Now these three routers are going to be in one group for all these three protocol: Hsrp, Vrrp and Glbp. We'll do one by one. Now for host 1, you saw me configuring, and for host 2, I just change one number here. That becomes the IP address of the second host. I copy this and paste it to the next device. Yeah. So this is the configuration on second PC. This virtual IP address can be any IP address in the same subnet. Now I want to use the last IP address in that subnet. Why? In case if I have more and more computers adding day by day, I still remember what address I have given as a gateway. So I'll not use this address to any other host because I have given it as a Hsrp address or Vrrp address or Glbp address. For me to remember, I'm giving the last IP address. It can be any IP address in the same subnet. It can be 10.1.1. or because it is 255, it can be 10.0.0.15, 10.0.0.65, can be anything. This is not something like universally agreed on floating address, nothing like that. So for computer 3, I'm just changing one IP address, 3. Right. So this is for router 3. I copy this and paste it to router 3. Sorry, it's not for router 3, it's for PC3. So PC3, done. Alright, next is the PCs are ready now. Now if you ping from this one PC to other PC, definitely they will ping because it's a normal switching. If I ping from here 10.0.0.2, I'm going to ping. There is no doubt in it, because of Hsrp I'm losing some packet. No, this is not Hsrp. I think I forgot to say no shutdown. I have given no shutdown. Try one more time. Okay, see, this is the wrong interface. It's fast Ethernet 01. So on R2, anyway, I checked it. It's good. Interface fast Ethernet 0/0, no IP address. It should be on interface fast Ethernet 01. IP address is 10.0.0.2.255.255. Okay, on one interface I have given it in a connected to a different interface name. That's why the problem. Okay, now let us try pinging from second PC to the other two PCs. Ping 10.0.0.1. I'm able to ping. It will this time. Okay, again the same problem. I didn't say no shutdown. Alright, so likewise I should also ping 10.3. It's a normal switching. There is no first hop redundancy, there is no routing, nothing. So let us enable these routers, these 4 routers. Let me start from router 4. On router 4 I got serial interface, or let us finish router 1. Sorry, let us finish because we already got fast Ethernet in it. So this IP address will be 4. And there is no default route. We are going to have a routing protocol. It can be EIGRP or OSPF or anything. I'll enable EIGRP. So I'll say router EIGRP autonomous system 10 network all networks, no auto summary. Fine. Now there is also another interface on the same router, which is interface serial 2/0, whose IP address is 14.0.0.1 255.255.255.0. No shut. That's all. There is no more configuration on R1 as a default configuration. Hsrp, Vrrp, Glbp configuration will come later. Okay, R1 has got the configuration in place. Let me finish R2. R2 has got 5 here and it has got 24, 2 here. No more changes needed. Copy, paste it on router 2. Next is router 3 has got 6 here, and here it will be 34.3. No other changes. Router 3 done. Now the last router, the internet router. So on internet router we have only serial interfaces. We got 3 serial interfaces, so I'll say serial 2/2, whose IP address is 24.4, and 2/0 has got 14.4, and I got another serial interface, that is 2/2, which is 34.4. So same EIGRP, I am pasting it on router. Yes. Oh yeah, you're right. It is 2/1. 24 is 2/1. Thank you. Thank you. Select all, copy, paste it. Yes. Where? Okay, serial. Thank you. Thank you. Copy, paste it again. Alright, so now I should see 3 neighbors in the adjacency table. Show IP EIGRP neighbor. Wonderful. Okay, we got 3 neighbors. Now one more thing I want to add here on R4 is loopback interface. Interface loopback 4, IP address 4.4.4.4, 255.255.255.255. Interface loopback 44, IP address is 44.44.44.44, 255.255.255.255. And one more thing, I want to do it on all these 3 gateways. On the 3 gateways R1, R2 and R3, I'd like to enable telnet for some verification. So I'll say line console 0, login, password Cisco 123. Copying, pasting it on R1, R2 and R3. R1 is ready with the password. It's ready for the telnet. Not on R4, not necessary. R2 ready for the telnet. R3 is also ready. Okay. Now password is set, it is enabled. Fine. Now next is now if I go to the computers and try to ping, definitely I'll not be able to ping 10.0.0.254, which is my gateway. This is my gateway, but I cannot ping. Why? This is not the physical gateway. This is a virtual gateway that I'm going to configure through Hsrp or Vrrp or Glbp. So as long as that is not configured, you are not able to ping. The other one, if you don't have a gateway, then you cannot even ping the internet. You cannot ping internet. So first, we need to enable that virtual gateway. Let's start with Vrrp. Why I'm starting with Vrrp? The reason is it's widely seen around the globe. Though it is not supporting IPv6 as for now, but it is widely seen all over the globe. It's not a proprietary one, so most of the people use Vrrp so that they can handshake with a non-Cisco router as well. Right, so let's see Vrrp first. What we learned about Vrrp? Vrrp is an industry standard. Vrrp will have master and backup. So there will be one router selected among these three as master, and the other two will be backup. And one more thing we learned, there is preemption enabled. So even though I am enabling Vrrp on router 1 first, router 1 may become master initially, but when I enable router 2 will say, no, I am the master because I got the bigger IP address. Though the priority, there is a tie, 100, 100, 100, though the priority is same, the IP address is different. This IP address, 10.5 is bigger than 10.4, so this will become master. When I enable an R3 will become master, and these two will go backup. So let's see that. I am on router 1. I'm going to enable Vrrp. To enable Vrrp, you need to get inside this interface, which is your gateway. This is your gateway. This is first hop redundancy protocol, first hop resolution protocol. Your PCs are not resolving with your serial interface on the other side. For the gateway, it has to resolve with this fast Ethernet interface. So you need to go inside that interface. Go inside that interface and say IP Vrrp the group ID. I need to give a group ID. Let's say 1. Now this is the ID that I was talking about in the MAC address. In the MAC address, the last two numbers GG I wrote. Because I'm typing 1 here, the GG will become 01. And then what IP address I want to give? 10.0.0.254. Vrrp is enabled. Just so soon. See, it was in the initiation state. From the initiation state, it was sending hello, and then it said slowly, okay, I'll be a backup. I don't know, maybe someone may be master, and then slowly it waited. No one responded. So from backup, it again went to initiation state, and then again from initiation state to it said, I'll try one more time. I'll be backup, and then still again no response. For 2 seconds, the third second it says, okay, I'm going to change myself as master. There is no one there to take the role of master. So this has become master. You want to verify that? I'll show you. Show Vrrp. Now it says this is the master. See the MAC address. This is what the MAC address we were discussing. For Vrrp, the MAC address that we were discussing is 00005E, the multicast, and then 0001. This GG will be the group number that we said 1, so it is 01. And advertised interval is every 1 second, and the master downtime is 3 point something based on the calculation which we were discussing. And you see the preemption is enabled by default, and the default priority is 100. Now if I go to this computer host 1 and try pinging my gateway. First I'm going to ping my gateway. Ping 10.0.0.254. I will get response. From whom I'm going to get response? It is from router 1, because router 1 is now master. Router 1 is having that floating virtual router, floating IP address, virtual IP address. What is the proof? I'll trace route and show you. Trace route 4.4.4.4. Sorry, do trace 4.4.4.4. See, it goes to router 4. Sorry, if it goes to 10.0.0.4, which is router 1, and from there it goes to 14.4, which is having that 4.4.4.4 on it. And now what I'll do is, I'll also show you one more proof. Telnet. Which address? The gateway address. 10.0.0.254. Now if I telnet to this address, if R1 is the hero, if R1 is the master, that should respond. One more time. I set only the console password. I'm very sorry. It should be line VTY. Okay. So telnet was not enabled actually. It was only console. Alright, so VTY is enabled here. Let me also enable on the other two devices. Right, so password is given. Now if I telnet from the first computer, it will telnet and it's asking the password CISCO123. See, I'm seeing router 1. Router 1, which is our current master. Let us enable Vrrp on router 2, the other gateway. Now router 2 should become master because it has got the bigger IP address than router 1. Let's verify that. Get inside the interface fast ethernet 0/0. Is that right? Yes. Fast ethernet 0/0. 10.0.0.5 is the interface, which is bigger than 10.0.0.4. So I'll say here Vrrp group ID. It should be the same group ID. You cannot change that. And then I'm going to use the IP command and give the floating IP address, same floating IP address 10.0.0.254. Now you see this is also slowly from init it went to backup, and from backup again it because the preemption is enabled, this says I am the hero, so it goes from backup to master. Now if I go to R1, which is our old master, see, old master says I'm changing myself from master to master to backup for group 1, because in group 1 I find another router with the higher IP address. So if I type now show Vrrp in the first gateway, I see this one showing as backup. And now it is showing the master is not me, it is 10.0.0.5. But both the routers, the priority is 100. See, the local router is also 100 priority. The master is also having 100 priority. So the reason why this is master is the other router is master is my IP address is 10.0.0.4, the other IP address is 10.0.0.5. For both, the virtual IP address is the same, the MAC address is the same. This is not going to load balance, so it's the same MAC address, but this MAC address is not really active here. It is active only on router 2. Now if I trace route, previously when I trace route it was going via 10.0.0.4. Now if I trace route, it will go via 10.0.0.5. See, it goes via 10.0.0.5. This one delay was because of the new MAC address learning. Now the MAC address should be learned on this interface, not on this interface. The same MAC address need to respond on this interface. This is the active device now. That's why the response was not there from R1, so it switched to R2. Now if I'll go and enable on R3, you know the story what will happen. Interface fast Ethernet 0/0, Vrrp, group ID, and the IP address is 10.0.0.254. Now this is also going to say I'm the master and the other two will be kicked off from the master. So other two are going to be a backup. Now this is the master, the ultimate. You got only 3 here in the group, and this has got the highest IP address. So this will remain master now. Show Vrrp. Now we see here this is the master. This is the master. The local is the master, and the master priority is 100. You don't see this local word on the other router. When we were seeing here, master is someone else. It's not local. So if I check on the second router, the X master, not this one. Now it says I have turned myself from master to backup. So this is gateway 2. Let's take it, show Vrrp. And here we see that master router is this 10.0.0.6. It is not local. And the priority is 100.0.100. See the MAC address, it's the same. Even on current active device. Now let us verify. Go and telnet now. I should see the response coming from 10.0.0.254. So it should come from router 3. I'm saying Cisco 1, 2, 3. I see router 3 now, which means that's the current gateway. So if I trace route now, it will go via 10.6. You see, it goes via 10.6. not via 10.5. Now if master goes down, if R3 goes down, you know, R2 will become the master. Let's quickly verify that. R3, I'm going to shut down the interface. Fast Ethernet 0/0. I'll just cancel the Glbp command. Sorry, Vrrp command. Now what happens when I trace route from here? It will start going via router 5 automatically. Let me telnet first. Now this is telnetting actually R2. See, I see R2. And now if R3 comes back, I'm just going to put the command back. In 4 seconds, this will become master. Now if I do the same telnet, previously it was R2, now it should be R3. One minute. Let me try one more time. Sorry. So we see router 3. So this is how the switchover happens. We can also change the timer. Now how to change the timer? Very simple. Let me first get out from here. I'll go to router 3 and show you how to change the timer. Right now the timer is like this. Show Vrrp. Advertised interval is 1 and then the master is this. So if I change the timer, see what happens. Interface fast Ethernet 0/0. So on fast Ethernet 0/0 I say Vrrp, same group ID, timer command. Now you can give the advertised time in millisecond if you want. By default it is 1 second. You can also give it in seconds. If I say 750 milliseconds, so first I need to mention millisecond, 750 millisecond. See, you don't have an option for master downtime. So now the timer is 750 millisecond. Every 750 millisecond this is sending the hello. Now if I type show Vrrp, you can see that the master interval is changed in some 2 point some fraction number based on this input. Previously it was 3 point something. I'll show you. Previously it was 3.69 because the timer was 1. Now since I reduced the timer from 1 second to 750 milliseconds, less than a second, this also has gone down and you saw the algorithm how it is calculated. Alright, so that is one. There is one more nice concept in Vrrp, that is learning timer from the neighbor. Means, if the timer is not matching, see here the timer is 750 millisecond, but if you go to router 2, the timer is not in sync. It's very important. Timer need to be in sync, otherwise it will fluctuate in real scenario. Here the timer is not in sync. Now I want to tell router 2 and router 1 that learn time from your master. How to do that? Go to the interface and say Vrrp group ID timer. You also have a command called learn. So learn from the current master. I say learn. After saying this, I'm expecting a change. Show Vrrp. I'll pull down the master once and then I'll bring down the master. Interface fast Ethernet 0/0 shut down. Now I'm expecting the other to become master. Okay, it has become master. Now I'll bring it again. I'm expecting this will go and do some impact there. No. So I have also tried this one many times. It is theoretically Well, the learn command works, but I don't see practically happening. Show Vrrp. In here, whatever we configured, it is there, but it is not reflecting on. But the purpose of learn command is to learn from the master. Let me also give the same command in master and see whether it will do some impact on the other. Interface fast iterate 0/0 Vrrp 1 timer learn. Okay, cannot learn timer while. Okay, this is the reason. Okay, so this is the reason. So let us change some timer. So here I'll make it as timer advertise maybe every 3 seconds you advertise. So I changed to a the default is 1. I changed to a bigger number. Show Vrrp. Okay, here it says because I changed 3 here it is 9.609. Let us see whether it has impact here. So previously in the backup routers we were having 1 and 3.609. Wow, wonderful, it impacts, but not in the advertised time, but in the master time. It do impact in the master time. So it is going to keep on advertise only every second, but it will wait for master to become down for this many seconds. Learning. Nice. Alright, so if it is in the millisecond, it's not going to happen. It needs to be in seconds. So this is what Vrrp. Now let us get into Hsrp. I'll cancel this Vrrp. From here, interface fast iterate 0/0 from here. Done. Interface fast iterate 0/0. Cancel. Sorry, not on the host, on R1 router. No Vrrp group 1. That's it. This is enough to cancel. Now show Vrrp. Nothing. I'll check on the other 2 routers before we start Hsrp. Show Vrrp. Nothing. Show Vrrp. Nothing. Oh, still something is here. Interface fast iterate 0/0. No Vrrp 1. So the group will be removed. Show Vrrp. I must not see anything. Okay, I'm not seeing anything. Now let us go and trace route or ping, do something. It should not happen. If it's trace route, it should not happen. This is based on the ARP inspection which we were having before, but this will not be there when the ARP gets refreshed and your MAC table gets refreshed. This is not possible actually because there is no real gateway anywhere. Now if I ping to this address or telnet to this address, see there is no response. TCP can easily identify using the sessions. Now if I ping or trace route, because trace route uses ICMP, this will happen as long as the memory, the buffer has got. So let us clear the ARP and try on R1. Show ARP. So this has got, see, it has got the MAC address. This is the you can easily identify what MAC address it is. It is Vrrp MAC address. Because it is here, the trace route is happening. But if I say clear ARP, so now nothing is there. Oh my god, it's still there. Clear ARP, sorry, not show ARP, clear ARP. Clear ARP on interface fast Ethernet 0/0. Show ARP. Okay, now it is gone. We don't have that Vrrp's address. Tracing route now will not be possible. See, there is no one responding now. It will never learn the MAC address because there is no router R1 or R2 or R3 going to respond for that floating address. Let me stop this trace and let's enable Hsrp on router 1. Interface fast Ethernet 0/0. Same like Vrrp, the command is same. Standby, group ID, IP address. Done. So here Hsrp is enabled. This will wait for 10 seconds and this will become active device. Here active standby. This will become active device. I want to show you here. Show. Command is not Hsrp. Standby is the command. For Hsrp, standby is the command. See, it has gone from standby to active. It was waiting in standby for 9 seconds and the 10th second it has made itself as active because there is no competitor. So now show standby. I can see that this is the active device and see the MAC address 000C 07AC which is the Hsrp ID, and this is the group ID, and that's the MAC address in use. Alright, so now next is, see, the priority is 100 and the active router is local router. I see version 1 running by default in this iOS. We can turn on version 2 if you want. Now preemption is disabled. That is very, very important here. The reason why I'm showing here is if I go to other routers and enable Hsrp now, they are not going to come as active. Why? There is no preemption. Though they got bigger IP address, because there is no preemption, they are not going to become active device. So if you want, then you need to enable preemption. Now let us go to router 2 and enable Hsrp. Interface fast Ethernet 0/0. Standby, group ID 1, IP address is 10.0.0.254. And also I'll enable it on router 3 now. Interface fast Ethernet 0/0. Standby, group ID 1, IP address 10.0.0.254. Alright, so now what happens is this guy has gone to standby listening. Okay, now R2 has gone. Let's see, show standby. This is in a listening state. There are chances for R3. No, anyway, they are going to be standby only because R1 has already taken the role of active. These two should go only as standby. It's in a listening state. It will take it's a bit slow because the timer is, you see, the timer is 10 seconds. The hello timer is 3 and hold timer is 10. So it will be a bit slow. It won't be that fast like you saw in Vrrp. But if you want to change the timer, you can change the timer. Since there are 3 routers, it's still in listening state. It'll take some time. Let me go to router 3 now and try the same command. Show standby. Now you see the router 3 has become standby. It has gone to standby. And the MAC address is not in use because this is not the active device. Router 3. Let's go to router 2. It's still in listening. Let me... Yeah, this will remain listening. There will be one active, one standby. All the other remaining in the group will be in listening state only. They don't go to standby also. So the standby is the next biggest. So between these two there was a competition because I enabled R3 very fast. As soon as I finish R2, within 10 seconds I enable. So R3 has won the election and R3 has taken the role of standby. And R2 is in a listening state. It will be always in listening state. Now, if R1 goes down, interface fast Ethernet 0/0, I am shutting down. Now, who has got the chance to become active? It is R3, it is not R2. The reason is R3 has got standby, so it will become, see, it has got the message. Okay, this is Hsrp message, sorry. See, it has already turned from standby to active. So show standby, so this says I am the active and the MAC address is in use. Now if I go to router 2, it will be in standby. See, it has moved from listening to speak and from speak to standby. So show standby now. Sorry, yep, correct. Show standby. Now I see that R2 has become standby. Let us bring R1 up. So this one will go to listening now. Since there is no preemption, this will go to listening. Show standby. Okay, see, it is in listening state. MAC address is not in use, and this will not become active or standby unless you enable preemption. Now what I'm going to do is I'm going to increase the priority. All other routers are having 100. For this I'm going to give priority as 150, which is not default. Default is 100. I'm going to give 150. Even after enabling priority, it won't come. R1 will not become active unless I enable preemption. I'll also enable preemption so that R1 will become master and R3 will become standby. Right now R3 is the active device. R3 will become standby and R2 will go from standby. Right now R2 is in standby. It will go from standby to listening. Let's check it. So on R1 what I'll do is I'll go under interface fast Ethernet 0/0. I'll say standby group ID 1. First let me enable priority. The priority, the maximum is 255. I'm giving 150, which is 50 higher than the other routers. Done. After this, there is no use if you don't have preemption enabled. If you want R1 to be always active, whenever R1 is alive, I want R1 to be active. If you want that, you need to enable preemption. See, though the priority is high, it is not going to take the role of active. It is going to standby. It has taken the role of standby from R2, but it is not going to active. It will not go to active. For active state, it has to win the election. For that, preemption is needed. Show Vrrp, show standby. You see here this has become standby because of the higher priority, but it is not becoming active. The reason is preemption is disabled. The active router is still router 3, but whose priority is only 100. Router 3's priority is only 100. 10.0.0.6 is router 3. So if you want R1 to take the role of active, I need to change the prior preemption. I'll say standby preempt. Standby group ID preempt. Now you're going to see this will take the role of active because this has got the highest priority. Now let's verify. Show standby. Here I see that we got 150 configured priority, and this is the active one, and MAC address is in use. If I go to router 3 should have taken the standby role now. Previously it was active, now it has gone to standby, and router 2 would have taken the listening. See, from standby it has gone to listening. So this is how Hsrp works. Now there are many more things. You can change the timer, you can trace the interface, the other interface. I would like you to go through the video which we have in our channel, which talks about few things which is not here, but in this we have covered more than what is there in the other video. In the other video I show some trace command, but all those things are not much popularly being used to trace. There are a lot of other technology to do that, but it is there in that video. Kindly watch that, the tracing the route using Hsrp. Now you can also change the timer. Let me quickly show the timer change in Hsrp. Same like Vrrp, you go under interface fast Ethernet 0/0, standby group ID 1, timer. See, here also you can change in hello timer milliseconds, or you can do it in seconds, but there is no listening, there is no learning, there is no timer learning from active device. There is no command like that. But here you're allowed to change both hello as well as the hold time. So hello time, if I want to change, I can say timer every millisecond. How many millisecond? 500 millisecond. Every 500 millisecond. Is it allowed? 500. Let's see the smallest. Yeah, 500 is allowed. 500 every 500 millisecond. Send the hello, and the hold time. You can say in millisecond. You can also say in seconds. I'll say the hold time will be 2 seconds. Sorry, 2 minutes. Sorry, 2 seconds. 2 seconds. I'm not going with milliseconds. 500 millisecond is hello. 2, or keep it as 3, because the others are saying hello every 3 seconds. Otherwise it will fluctuate. So you can change the timer like this, but you need to change on every router manually. No learning from the active device. Alright, so that's about Hsrp. I'll show quickly Glbp. No standby 1. I cancel Hsrp on all these 3 device. Right, so before we enable Glbp, show standby nothing, show standby Nothing here also. Router 2 show standby. Now GLBP is same. Interface fast Ethernet 0/0. I'll say GLBP ID IP address. No difference. But there will be a difference in one place. I'll show you. So GLBP same like Hsrp. You can change timer. You can enable via preemption. You can change the priority. Now I'll just paste this thing in all the three routers now. R2, R3 interface fast Ethernet 0/0, R1, done. Now if you see the active device, it will be 2 if it is within 10 seconds. Yes, the active device is router 2 because I enabled first this router. There is no preemption for this active. Show GLBP. You see there is a big list of things that we need to see here. I got 3 routers, so I got 3 forwarders. In this 3 forwarders, forwarder 2 has got this MAC address. This is the group ID. 01 is the group ID. 02 is the forwarder number. 03 is the forwarder number. And you see the owner's MAC address. You know whose MAC address is this? This is the MAC address of other gateway. This is not forwarding for those computers which has got this MAC address in the ARP table. This router will be forwarding. That may be router 3. See, what is GLBP? All router will be active. But you see here, this active is different. This active talks about AVG. What is AVG? The one who decides on the MAC address and distributes the MAC address. For router 2, it has kept this MAC address. Okay, I'll respond to this MAC address. I am this. For router 3's MAC address, it has copied. For router 3, it has given GLBP's MAC address. Sorry, this is router 3's MAC address. This is router 3's MAC address. You can see it here, 10.0.0.6. It has given a virtual MAC address, separate virtual MAC address. Likewise, for router 2, it has given a separate virtual MAC address, 103. So this job is taken care by AVG, the active device. This is active as a AVG. But there is another active for forwarder 1, meaning anyone who comes with this MAC address, I will be forwarding, which is local router. I am the forwarder. But whoever comes with this MAC address 102, 101, I am responsible. I am active. 102, you will see someone else is responsible. Let's see R3. Show GLBP. In here, if you see, this is active for forwarder 2, that is 102. And if you go to router 1, that will be active for 103. Show GLBP. And this will be active for 103. Listening for the other 2. So all 3 are busy in forwarding the traffic. So because I got 3 gateways, these 3 PCs will be using separate gateway. This will be using R1, this will be using R2, this will be using R3. Let's see whether it is really happening. Telnet 10.0.0.254. CISE0123. Router 1 is responding. You know that is the first forwarder. telnet 10.0.0.254. CISCO 123. Look at this, how beautiful. First PC is using R2 as a gateway. Same address I am telnetting. Second PC is using, this is the second host. It is using R3 as a gateway. Now if I go to the third computer and telnet 10.0.0.254, it will use the first gateway, router 1. So all three are actively forwarding the traffic. This is what called as gateway load balancing protocol, GLBP. Hope you understood all these three first hop redundancy protocol. If you have any doubt, you can ask me now. Yeah, last two numbers will increment. For forwarder 1 it is 01, for forwarder 2 it is 02, for forwarder 3 it is 03. The before two number is your group ID. This is your group ID. No, don't go to other case. Yeah, in the other case it is static, only one active device. All the others are going to be backup or listening or standby. So you need not to increment the last two digits. So the last two digits will be used for group. So in the other cases only this will be based on your group. This will not be affected. This portion will not be affected in Hsrp and Vrrp. Only this portion will be according to your group number. Whereas in GLBP, your group number goes to this position and your forwarder number comes here. No, it's like this. There are three MAC address generated. Now first guy comes, AVG will say, okay, I'll give my floating MAC address to this guy. When the second request comes to the same MAC address, AVG will say, let me give the router 3's MAC address. So AVG will give router 3's MAC address. So packet will be forwarded to router 3. And no, it is same, who came first? R2 you configured first. R3 you configured second. R1 you configured at last. Correct? Who is standby now? R3 is standby. Who is listening? R1 is listening. It is like that. The time in which the association happened, the interval. Yeah, the first will become active and he will be the forwarder for group 1. The second will become the standby, that will be the forwarder for group 2, forwarder 2. And the next guy will be listening and he will be forwarder for the third guy. So if I have the fourth computer, R2 will be the forwarder. It is round robin method. If I have the fourth PC, R2 will be the forwarder. For R1 and R4, for PC1 and PC4, R2 will be the forwarder because that is the master now. Is that clear, ma'am?